You're on a pen test. 200 IPs to scan. Thousands of credentials to brute force. A report due Friday. You could do it manually. Or you could write a script that does it while you sleep. That's what this chapter is about. Scripting for penetration testing. Not becoming a software engineer, just learning to read, modify, and automate the repetitive work so you can focus on what actually matters. Let's say you're testing a company called MCDS LLC. Your goals: port scan their entire network and save results per IP. Then run reverse DNS on every address. Doing that by hand would take hours. A script takes seconds. 3 languages dominate pentest scripting: Bash, PowerShell, and Python. Bash is your go-to on Linux and macOS. It's the default shell. A Bash script starts with a shebang. That's the line that tells the OS to use the Bash interpreter. Then whatever commands you want to run. Save it with a .sh extension, make it executable with hmod, and you're done. PowerShell is Microsoft's answer. It started on Windows but now runs everywhere. The catch: Windows blocks PowerShell scripts by default. You'll hit a restricted policy error. Fix it by changing the execution policy to remote signed. Your own scripts run. Downloaded ones need a signature. Save with .mes eps1. Python is the big gun. General purpose, interpreted, and it has libraries for everything. Save with .py. One thing to watch: indentation matters in Python. Get it wrong and the code breaks. Now let's talk about what scripts actually do. Variables store information in memory. Imagine a cupcake shop that halves prices on Tuesdays. You set a variable for the price, divide it by 2, print the result. That's a variable in action. Arrays let you store multiple related values. 10 student ages, 1 array instead of 10 separate variables. And yes, most languages start counting at 0, not 1. That's called zero indexing. Different languages handle variables differently. Bash uses the $sign to reference them, no type declarations needed. PowerShell also uses $signs but infers types from context. Python needs no special characters at all. Just assign and go. Comparison operators let you check if values are equal, greater, or less. Bash and PowerShell use word-based operators like eq, neqelt, neqet. Python uses the familiar equals equals, less than, greater than symbols. String operations are everywhere. Concatenation means joining strings together. Bash just puts variables next to each other. PowerShell and Python use the plus sign. But watch out. Python won't let you concatenate a string and a number directly. You have to convert the number to a string first with the straw function. URL encoding is another string operation. Spaces become %20, ampersands become %26. PowerShell has it built in. Python needs a module. Bash doesn't have it at all. Now for flow control. This is where scripts get powerful. Conditional execution. If this, then that, otherwise something else. Every language has it. Bash uses if, elif, else, and phi. PowerShell uses if, else, fif, else with curly braces. Python uses if, elif, else with colons. The exam will show you code snippets and ask which language it is. Look at the syntax. Curly braces mean PowerShell. The phi keyword means Bash. Colons and elif mean Python. Loops repeat code. For loops, run a fixed number of times. Perfect for scanning every IP in a subnet. While loops run until a condition changes, like brute forcing passwords until you find the right one. Bash for loops use a brace range, 0 through 255. PowerShell uses start, test, and increment statements. Python uses a range function that includes the start but excludes the end. While loops work similarly across languages, a password cracker might loop through mic0, mic1, mic2 until the test function returns true. The loop exits when cracked becomes 1. Input and output management. Redirect output to a file with the greater than sign. Append with double greater than. Pipe one command's output into another with the pipe symbol. Netcat can listen on a port and write to a file, or send a file to a remote system. CSV, separated values, is the universal format for tool input and output. Simple, flat, and everywhere. Error handling prevents scripts from crashing. Python uses try and except. PowerShell uses try and catch. Bash has no built-in error handling. You write it yourself with conditionals. This is one reason developers avoid Bash for production code. Reusing code saves time. Classes are templates for complex data. Functions are reusable code blocks. Libraries are collections of functions and classes you can import. Now the automation tools you need to know for the exam. PowerShell modules. Empire is a post-exploitation framework. PowerSploit is a collection of pentest scripts. PowerView maps Active Directory. PowerUp SQL attacks SQL servers. AD search queries Active Directory for user and group info. Python libraries. Impacket gives you low-level access to network protocols. SMB, RDP, LDAP. It's your tool for man-in-the-middle attacks and lateral movement. Scapy lets you create, send, and manipulate network packets, essential for custom scans and spoofing. Breach and attack simulation tools. Caldera is MITRE's automated adversary emulation system. Infection Monkey is open-source malware simulation that spreads through networks. Atomic Red Team provides lightweight tests mapped to the MITRE ATT&CK framework. Common automation use cases. Scan systems and trigger follow-up actions based on results. Analyze target configurations. Modify IP addresses across hundreds of routine activities. The key takeaway: you don't need to be a programmer for the PenTest Plus exam. You need to recognize the language of a script, analyze what code does, and insert code segments in the right place. Bash for Linux, PowerShell for Windows, Python for everything else. Scripting turns hours of tedious work into seconds. That's the skill that separates a good pen tester from a great one.